no records of luxuries. She cannot even imagine on her meager salary. Then one day, with just vibes.
All right, continuing with the no calculator multiple choice, number 21. The graph of a function f is shown above. What is the value of the integral from 0 to 7 of f of x? So, good review of what does an integral mean. From 0 to 7, the area under the curve of f. And then we always just double check. Is this actually our graph of f, or did they give us a derivative? Nope, we're good to go, so that's the graph of f. So it's just a geometry area problem. Got some positive area, got some negative area. Let's do it. I'm going to call this a trapezoid. 1 plus 2 divided by 2 times 2 is 3. And then let's go, well, 2 by 2 is 4. 2 by 1 divided by 2 is 1. And then our negative 2 by 2 divided by 2 is 2. 3 plus 4 plus 1 minus 2 is 6. There we go. Number 22 says the function f is continuous for all real numbers, and the average rate of change of f on the closed interval is negative 3/2 from 6 to 9 with a c in between. There's no value of c such that the derivative equals negative 3/2 of the following, which must be true. So when it says that, nowhere does the derivative equal negative 3/2. It's kind of the reverse of our mean value theorem. So the mean value theorem says that if the average rate of change is negative 3/2, then there has to be at least one point where the derivative is equal to that point. So if this says there is no value, that means it does not satisfy the mean value theorem. And the mean value theorem says that it has to be continuous and differentiable. So really the only good option is E. Let's take a look at a couple of these others. This one would be finding the average value, which is a good thing to know. This one would be saying the area doesn't exist, which we can't determine. Even if it's not differentiable, like say it looks like this, the area still definitely exists. This one would be finding the average derivative, and then this one would be saying it's always decreasing, which definitely does not have to be the case. It can increase a little bit, decrease a little bit. So E, not differentiable. The mean value theorem, good to go. 23, let f be the function defined by f of x is 2x plus e to the x. If g of x is the inverse of x, that's how we've got to read that, for all x, and the point 0, 1 is on f, what is g prime of 1? So always my strategy here is to derive the inverse. F of g of x is x. That's our definition of the inverse. And if we use the chain rule over here, f prime of g of x times g prime of x equals 1, and we divide, we get our inverse derivative. G prime of x is 1 over f of f prime of g of x. So if I want g of 1, g prime of 1, I want 1 over f prime of g of 1. Do I know what g of 1 is? I do not, but I know that f of 0 is 1. So then because of that, I know that g of 1 is 0 because they're inverses. So now I need 1 over f prime of 0, which means I need the derivative of this. F prime of x is 2 plus e to the x. F prime of 0 is 2 plus e to the 0, which would be 3. So my answer is 1/3. Look at number 24. The function g is given by g of x is this. What is the absolute minimum on the closed interval from -2 to 1? So to find critical points, we want to set the derivative equal to 0. So let's go for g prime of x is 12x squared plus 6x minus 6. Set that equal to 0. Factor out the 6. 2x squared plus x minus 1. 2x x plus 1 minus 1. So x equals 1/2 and x equals -1 are our critical points, which both of those are in our interval. So then let's look at our first derivative test, see which one is the minimum. -1, 1/2. So if I go lower than -1, I'm going to get a negative times a negative, which is a positive. If I put a 0 in, I get a negative times a positive, which is a negative. And if I put a number bigger than that in, I get a positive again. So our graph looks, we should know our graph looks something like this. So I do have a minimum here. Now the question is, on the closed interval, so I need to check my bounds, f of -2, my local min, maybe, -1/2, and then my other bound. Let's take a look. If I put in -2, so putting in -2, I think we get 4 times -8 plus 3 times 4 minus 6 times -2 plus 1. We get -7. Putting in -1/2, we're putting it into the function. 4 times -1/8. 3 times 1/2. 6 times -1/2 plus 1. What is that? -2 minus 1.5 plus 3 plus 1. -3.5 plus 4 is actually positive 0.5. And then if I put in 1, I get 4 plus 3 minus 6 plus 1, which would be equal to 2. So what is the minimum value on the closed interval? That's actually going to be -7. I do like that you couldn't get this wrong if you'd have answered with just your x value, local min of 1/2. That's good. We didn't trick you there. So what did this graph look like? You know, without a graphing calculator, it probably looks something like this, where that value at -2 was somewhere down here. We did get the local minimum at 1/2, but on the closed interval is actually something lower down there. 25 is an awesome differential equation review. If dy dx equals e to the y plus x, with the initial condition of y of 0 is negative natural log 4, we've got to find the solution to the differential equation. So we got to separate our variables. But there's addition in the exponent, so what should we do? Oh, good little Algebra 2 review topic. E to the y times e to the x is e to the y plus x. Now we can separate them. So if I divide the ey over, and I'm going to write that as e to the -y times dy equals e to the x dx. And then let's go ahead and integrate. The integral of e to the y is e to the -y divided by -1 or times -1 if you picture the chain rule equals integral of e to the x is e to the x plus c, which gives us our nice initial condition when I put a 0 in. Let's go ahead and solve for c quick. negative 1 times e to the negative natural log 4 equals e to the 0 plus c. The negative, of course, becomes a positive. E to the natural log 4 is just 4 with the negative here. So negative 4 equals 1 plus c. So c equals negative 5. So let's go ahead and finish that with this problem. I'm going to go ahead and erase some of this. Negative 1 e to the negative y equals e to the x minus 5. There's our c. Divide by the negative. E to the negative y equals negative e to the x plus 5. You can probably start seeing that's where it's going to end up here. Take our natural log of both sides. And we get the negative y right here equals the natural log of negative e to the x plus 5. Throw the negative over. There it is. So, separated the variables, integrated, solve for c, solve for y. Good work.